So welcome to my talk, which is on what's new in Scala 2.10. I'm going to talk a little bit about the actual things that we're going to put into this next release, which is going to come out very soon, but also somewhat about the philosophy behind Scala, where it came from, where it's going, and how did this shape the next release. Who here has already written Scala code? Okay, so I don't need to give you the background, I guess, for the benefit of those who haven't, just where it came from. So in the 90s, I was heavily involved in Java. I wrote a language called Pizza, which we named Pizza because if Java is a hacker's drink, then we thought it should be complemented by hacker's food, so that's why it's called Pizza. It was essentially an extended Java. And that led to GJ, and GJ led to essentially the core of Java generics. And during that time, I also wrote the compiler for Java, Java-C, which is the compiler today. So the standard Java compiler, of course, has undergone heavy maintenance and extension and so on, but the core is the Java-C I wrote in 1999. Over the last 12 years or so, I wanted to do something a little bit more radical than extending Java. Also, I found out that it's actually very hard to do because Java is a big legacy, it's a big language, it has lots of interactions which make it very hard to add stuff cleanly. So instead of being a superset of Java, the Scala experiment was to say, well, can we do something which is interoperable with Java, fully interoperable, but which gives you a nice combination of functional and object-oriented programming. And that started out as essentially as a research experiment. Can we do it? And then afterwards we wanted to find out, well, is it useful? Do people use it? And they did. And since then it has been grown a lot in open source and industry and so on. So what Scala is, that's the slide I have almost in every talk. I can't repeat it often enough. It's a unifier. It's a unifier first between this world of functional and object-oriented programming. And with unifier, I don't mean, well, it's two languages in one. It has an object-oriented subset and a functional subset, but really that it tries to take something and see it from both an object-oriented and a functional side. For instance, functions in Scala, they're actually objects. So objects equals functions. Modules from the functional side equals objects, and so on. And what that actually gave us, sort of by accident, was a language that's very scalable in the vertical axis. So it's used in a lot of applications, mission-critical applications in large enterprises and highly trafficked websites. But it's also actually a pretty good scripting language. So if you want to give a shout out for Scala, you can go to the Script Bowl, which is a competition of scripting languages where we have competed every year over the last years. And actually last year we tied, tied for first place. So maybe this year we're going to win. Oh, we won already. Oh, sorry. I was great. Oh, that's great. I thought it was going. Sorry, I got my time.
You didn't get the news.
No, I didn't get the news. That's very welcome. Excellent. So this functional aspect, that's really something that I was very fascinated to see how functional programming seems to be on the rise. As I said, I come from university, so I go to scientific conferences and also to Java 1 and developer conferences, but that's more lately. So in scientific conferences, there's essentially there were two main object-oriented conferences. One was called ECOOP, European Conference on Object-Oriented Programming, and the other is UPSLA. And 12 years ago, ECOOP had about 3 times the attendees of ICFP, which is the main conference on functional programming, and ECOOP had about 10 times the attendees of ICFP. Now ICFP has about 3 times the attendees of ECOOP. And UPSLA stopped existing as an independent conference. It's now one of the tracks of the Splash conference, so it's hard to tell what it is. But you see a clear trend curve in 2 different directions. And the other really amazing data point is that over 46,000 as of last count have signed up for the Coursera course on principles of functional programming in Scala that I'm giving. So 46,000. And it is a really hardcore functional programming course, so no, we're not going to dilute that. Industry adoption also is very, very widespread, and until very recently, the widespread opinion was that Scala is cool for essentially hot web startups with smart programmers, and it's true that a lot of them are using Scala very heavily for sometimes most of the things they do. But it's also true that lately a lot of enterprises are using Scala with large groups for very important applications. So yes, this is just a summary of some of the companies that do and that have no problem with being shown publicly. So you could ask, why now? Why is functional programming suddenly so important? And I believe it's really largely driven by hardware trends. So I think that's the immediate need why the industry is moving to functional programming. So here you see a chart on clock speeds, and we all know that they have pretty much flattened out. They're not getting faster anymore. That's a transistor count that's still growing exponentially for a number of years. Eventually that will probably level off as well. And right now here you see number of cores per chip, and that's also growing here quite significantly. And here we are just talking about multi-core, but you have to add other forms of parallelism, such as GPUs. So for instance, that's an NVIDIA Fermi, latest generation GPU. If you want to keep that fully loaded, you need 24,000 fully loaded threads, running parallel threads, 24,000. So you can imagine, well, that's quite a challenge from the software that we are currently writing. No? Okay, so in that new world, we have a triple challenge which comes from parallel processing. So how do I make best use of all these processing elements, whether they are multi-cores or GPUs or clusters or data centers? And the second challenge is asynchronous computing, because that's really forced on us in particular with essentially web services, that every computation is nowadays essentially an event processor that takes events and has to deal with them asynchronously. And finally, distributed, which has essentially all of the above plus the added dimension that things might fail, nodes can go down, and messages might be delayed indefinitely. And it turns out that in this world, that every piece of mutable state that you have is a liability. You have problems such as ensuring coherence of caching, whether these are hardware caches, where the hardware does it for us at a great expense in transistors and times, or in software we also cache all the time things. We have some piece of data here, we compute it, we cache it. Well, if then the underlying reality changes under us, then we have to invalidate those caches. So it's very hard to find out when to do that at reasonable cost. We have data races, that we have different computations that might give different results. We have versioning problems and so on. So the problem, if you look at it in a nutshell, and I would say it's this one. The problem is that computations that are built from concurrent threads that access mutable state, shared mutable state, are inherently non-deterministic. So here you have a simple example where we have a shared variable x, and we have two asynchronous computations which can run at any time. One adds 1 to the variable and the other multiplies it by 2. And depending on how you run these things, that can give 0, 1, or 2 in the end. And even if you say this async block is something that is atomic, so think of async as synchronized, then you can still get 0 or 1 or 2 depending on what order these two blocks are run, because that order is again not deterministic. So non-determinism then is caused by parallel processing and mutable state. And non-determinism is something that we are deeply uncomfortable with, because it means that most of my testing and debugging methodologies won't work anymore. Debugging means, well, the assumption on debugging is that I can replay things like they were when the fault came. If afterwards I see the things in a debugger and they won't happen anymore because the timing structure is different, then what do I do? We also, of course, assume that we can reproduce faults at our client on our machines. So again, if it's non-deterministic, that's by no means assured. So it's I think we are really not really. We are really quite dependent on this idea of reproducibility and replayability, and for that reason, non-determinism is something that's deeply problematic. So, parallel processing, that's something we can't avoid anymore. Hardware trends, software trends with data centers and so on is something that we say that's inevitable. The only thing in this equation that we can change is the mutable state. So we can try to reduce that, ideally maybe eliminate it totally, and if we have parallel processing without mutable state, then we can get back the deterministic computation. And programming without mutable state means programming functionally. So that is really the real reason why I believe functional programming has this sort of blossoming that even though it existed in research and academia for 1960, 50 years, it never really was very, very interesting for industry, except for a short blossoming in the 80s, where it was very much tied to AI and the Japanese fifth generation problem. At the time, it died off again because of hardware trends, because functional programming was essentially inherently tied to fancy exotic machines. And it turned out that at the time, every new generation of Intel or MIPS or SPARC microprocessors was faster than the fastest parallel machine people could build. So it was pointless at the time, and people would just go with normal processors, and normal processors would work very well with standard imperative programming. But it's the same hardware trends that now I think favor functional, because they essentially involve parallelism. So another way to look at this is if you have programmed functionally, and since most of you say you have already written Scala code, yeah, I guess that's true, then you know that writing programs, functional programs, feels completely different from writing imperative programs. Writing imperative programs is very much a matter of thinking of things in terms of time. I have to set this variable, then I can use it. I have to grab this lock, then I can enter the critical region, and so on. Whereas in functional programming, that doesn't enter the picture. In fact, there's a deep theorem, which is called the Church-Raza theorem of Lambda calculus, which says the order of execution in a purely functional program does not matter. You can execute it in any way you want to, including parallel. The result will always be the same. And that means that the thought process of functional programming is really quite different. You think more in terms of what do I need to build these things? I built this thing out of these other things, and then I have that assembly, and then I use that to build that other thing over there. And that, for lack of a better word, is really like thinking in terms of space. I build things spatially, one out of the other. And if we add parallelism to that, then thinking in terms of space is very compatible with that, because it just means that different things of my spatial structure get executed, get built by different threads. And since I think in terms of space, it doesn't really matter when they are built. They can be built in parallel. But when I think in terms of time, then I have a problem like this one, that I have all these different time threads, and if they intersect on some piece of mutable state, then I have a problem. I have a data race, I have to put in a lock to avoid this, so I have to put all sorts of preventive measures to keep these things tidy and not really conflicting. And we are really bad at coming up with these preventive measures, because that's not how we like to think, I believe. We like to think in terms of what's our objective, where do I want to go, what do I need to do that, rather than that mode here which says, well, think of all the possible bad things that could happen, all the data races, put in a lock to prevent each of them. But don't put in too many, because if you do, then you might get a deadlock, or you might get bad performance because you forego your parallelism. So it's sort of this tightrope where you say, okay, I want to put in the minimal amount of synchronization, because synchronization is expensive, and at the same time avoid all possible things that can happen badly. And that's something that's very, very difficult. We're not really adapted to that mode of thinking at all. Okay, you could say, so that was the case for functional programming. Should we all program in Haskell now? Well, maybe, but my opinion is actually not, so it's up to you. My opinion is that actually object-oriented programming is really valuable. What we've learned over the last 40, 30 years in object-oriented programming is very, very important. And in particular what concerns object-oriented analysis and design. Because the importance here is that it answers a central question, which is, what do you put where? In a large system, you can't really have this assumption of a global namespace anymore. Just dump all your methods in the global scope and you will deal with it. We know that that won't scale, that won't work for systems that go beyond a couple tens of thousands of lines, maybe. Once we go beyond that, it's hopeless. So we have to answer this question, how do we structure our program? And object-oriented programming has very good answers for that. So in the end, we need to put things somewhere, and OO can do that. Good. So I said we want to have functions and object-oriented programming. Does something in object-oriented programming have to change? Yes, I think we have to give it a little bit of different twists. So previously, there's one characterization which is very well known by Grady Booch, who said that objects are characterized by state, identity, and behavior. And I think he got it wrong in 2 out of 3 counts. So if you look at that, state, and by state, I believe everybody means mutable state, we just said we want to eliminate that, or at least reduce it. So that would mean that a lot of the objects we construct should not have mutable state. And of course, we know objects like that already from Java. Strings in Java, Java-lang string is a class that does not have mutable state. It's all immutable. And we want more of that. We want many more of that. So we want to get away from the case where the default is immutable state. I thought that was something that everybody accepted, that was uncontroversial, but I was actually recently at a conference with language designers, and I think it was both Guido van Rossum and Bertrand Meyer, the designers of Eiffel and Python, who disagreed, who said, no, objects need mutable state, otherwise they're not objects. You have to call it something else. So just to tell you, there is disagreement on this thing, but I believe really we have to get away from the mutable state. The other one is identity, and with identity, it's what one generally means is reference equality. So essentially 2 objects are the same if they're the same address. And I believe that's another notion that we want to get away from, where we want to have structural equality or user-defined equality, but not this sort of reference equality. And finally, behavior, yes, absolutely. Objects encapsulate behavior. Okay. So the other often quoted phrase and interesting phrase is, I think there was Martin Fowler who said, tell, don't ask. So that's a good idiom for object-oriented programming. Tell, don't ask. Well, that's problematic for functional objects because if you tell an object something, then it has to do something. And in the end, that would mean it has to change its state in some way, right? If you just tell and don't want to get a result back, then either it's a no-op or the object changes its state. You can't do anything else. So that also, we can't do that. So I believe what the advice is really fundamentally due is because of this von Neumann bottleneck, which says, well, we have this tendency to communicate with small immutable values. It's even embodied in Java, I would say, to say, well, I can return only a single thing. I can't return more than one thing. So we have this very thin pipe of what we return. And I think the functional way is to say, well, let's just ignore all that and return very, very rich things, whole object graphs. It doesn't matter because we wouldn't have a problem with ownership or copying or any of these things. So that's why I think that dogma here doesn't really apply once you buy into the other ideas of functional programming. Okay. So I told you that hardware trends were really the reason to adopt functional programming, and I think that's true. That's sort of the trigger. But once you do the jump, you really realize that there's much more to it. That object-oriented functional programming is also shines in terms of its simplicity, its productivity, and just the pure fun of doing things. So I believe these are sort of, in the end, more important for me than to just say we have something that runs well on parallel processes. But it's always that if you have an industry shift, then these are sort of soft factors that don't really count so much because you can't measure them very well. So often you have the first factor, which is a hard factor, which says, well, we must do this because otherwise we can't solve our problem. And then afterwards you say, okay, oh, this is great, what we did. Object-oriented programming was actually very similar when it came out in the 80s. There the big problem was to design GUIs, so graphical. So before, you had all these character-oriented screens, and then you had the bitmap screen. So you could do a lot of user interface, rich user interfaces, and it turned out that the previous mode of structured programming didn't work very well for these things. You needed objects, you needed dynamic binding, and so on. So that was the thing that really drove the industry to say, adopt object-oriented languages. And then afterwards, the secondary concerns were saying, oh, well, that's actually great for reuse and great for modeling. They also came in. But what really happened at the time, it was GUIs. Without GUIs, maybe it would never have taken off. Even though, in retrospect, that seems crazy. But I think really it is. You need sort of a forcing factor. Okay. So one thing I said here, simplicity of functional programming. And there you might wonder, because Scala got quite controversial and press and quite a lot of bad press to say it's so complicated, it's so terribly complicated. So how can I mention Scala with the same name as simplicity? Well, actually it turns out that Scala can be as simple or as complex as you like most programming languages. But I firmly believe Scala is best when it's simple, and it can be really, really very, very simple, much simpler than Java. So one example here is the Kojo environment, which is a wonderful learning environment for kids. It was Lalit Pant who did that. It's used in a school in India with, I think, hundreds of girls, aged 12 to 13. That's how they learn the first steps in computing and mathematics. So not the first steps in mathematics, but more. So essentially, it's an environment for computing and mathematics. It's all written in Scala. It uses Scala as essentially also the extension language for writing these things. Or there's Sadai Ladad. If you look him up on the internet, he has a series of absolutely great talks where he takes you through a set of problems, Euler problems, game of life, games, and so on. And he's extremely refreshing how he does that. He does it all in Scala, and it's very beautiful Scala. It's very easy to understand, and you see that he has fun. So what I wanted to do is, I can't be Sadai. I'm not nearly as funny as he is, but I still can try to give you a little bit of a spin to show you what the feeling is of this thing. So let me just open here the right package. Okay. So what I'm going to do is I'm going to use something very new, which is called a worksheet. Which will be released in the next version of the Eclipse IDE that we work on. So let's call this problems. Okay, so we have a problem. Oops, I just see that's not a good screen resolution. Let's change that. I must have jumped back. No, that wasn't it. Sorry? Oh, it's oh, sorry. Yeah. Okay. Yeah. Okay. Thanks. Apply. Yeah. Okay, there we go. So we see we have this worksheet, and what we can do is we can write stuff and have it evaluate the thing. So here on the right-hand side, it would always show you what we evaluated. We can also name things, so it's sort of like a REPL, but in the IDE, and you see both the input and the output on the same screen, on the same sheet. So what I want to do is, there's a nice site called 99 Scala Problems, so I've taken it from there. So the first problem we're going to look at is to say, well, find out whether a list is a palindrome. Palindrome is something that is the same no matter how you read it from the front to the back or from the back to the front. So how would you do that? That's an easy one. Well, we can write a function isPalindrome, and that should be a generic function, so it can work over all sorts of lists, and it gives you back, what should it give you back? Well, we still have to implement it. So I would propose xs equals xs.reverse. And there we go. So then we can write isPalindrome of xs. And it will tell us false. Let's do another one, is palindrome of, let's take a string, something like that. So that should be a palindrome. Oops, we get an error. So what does the error says? Oh yeah, we have a string and it wants a list. So our type here was too narrow, so let's change that and just say, okay, we want to apply that to arbitrary sequences, and then it would give us true. So you see, you have this nice way of thinking where you see all the time immediately what you're doing here. Let's take this a little bit further. So I want to do another problem. That's this one here, where we say, essentially what I want to achieve at the end is I want to get a run length encoding of a list. So if you have repeated elements like here, then what I want to say is, well, the list consists of 4 A's and 1 B and 2 C's and so on. You know what, you see what I want to do there. And the first sub-problem to get there is a method to pack consecutive duplicates of list elements into sublists. So you see an example here with 4 A's and a B. So we want to have the 4 A's in the list by itself and then the B in the list by itself, and so on. So how would we do that? Well, maybe let's do test-driven design, and let's do a test case first. So let's say the data would be A, B, C, D, E, A, something like that, 2 list. Okay, so now we have a list on which we can test that. So what we want to say, let's call this chunks. So that would be the chunks of the list of all the same elements. So that takes, again, it's generic. It takes a list of T. And it gives us back, what does it give us back? A list of T. And what is it? Well, I don't know what it is yet. We'll get to that immediately. What we can do is we can write already chunks of data. So that's our test case. So that should give us what we want. Right now what we get is we get a not implemented error, because it turns out that that's one of the cute new things in 2.10. So we have the triple question mark, yay. I'm normally very hesitant to put in symbolic operators, but this one is really worth it three times. So what that is here you see it. So its type is nothing, and it throws a new error every time you select it. It throws a new not implemented error. It's defined in class predef, which is the class that's automatically imported into every Scala program. All right, so we better do something about that. So let's do an implementation. Well, one standard way, if the problem is not solved immediately, is we pattern match on the list and say, okay, if the list is empty, what do we return? Well, there are no chunks to return. We return the empty list. And otherwise, if it's a list that consists of a head Y and some elements YS, what do we do? Well, then we need to split the list in two. The first one would be all the elements that are the same as Y, and the rest is the rest of the list. There's a function for that in the collection library. Not exactly sure what it is, but we can try it out. I think it's called span. So let's try this out here, span. And then what should my function be? Equals A. So, So yeah, it doesn't compile, of course. So let's just put another strategic triple question mark. And that lets me look at span. Yeah, span seems to do the right thing. It gives me a list of four A's and the rest of the list. Okay, cool. So let's delete the span here. It was just so essentially a quick essay, quick trial on the side. So what I want to say is, well, the first chunk and the rest should then be the list XS span. And what's my element? What's my test? Well, it should be, is the element the same as the element Y that I have here, because I want to collect all the Y's in here. And once I have that, I know that my first result is first, so that's the first sublist. And the rest of the result is what? Well, it's chunks. I have to do recursively for the rest, chunks of rest. I think that should be it. And if you have that, then everything becomes much nicer. Instead of the not implemented error, I have what I need here. Cool. So let's do one more step. That was this runtime encoding. Let's see what we do there. So what I want to write now is a function, def encode. And it has a similar signature as chunks, but it would return a list of a pair of t and an int, right? So we want to have the element and then the number of times it appears. Okay, and how would we write that? Well, let's start with chunks. Let's do chunks of XS. And so once we have done that, then we need to post-process it, because
Can you scroll, please?
Oh yeah, sure. Yeah. Yeah, I do some. Okay. Better?
Yes, please.
Okay. So you have chunks of XS, and now we need to post-process it. So we post-process each element, so that's a map. And that would take one of these chunks. And what should it return? Well, it should return the first element of the chunk. They're all the same, but let's just pick one, and the length. And so we have the encode function. And finally, we can test it with encode data. And there we go. Oops. We get the encoded list that we wanted. So what you see is it's a very nice way to interact with a computer, because it's so immediate. Essentially, there's no need to set up a file here, then go compile it there, start a build tool, run your tests, collect the test output. It's all in the same sheet. It's really like a spreadsheet or like a Mathematica sheet. Yeah.
Your example was easier because you knew the crucial function that made it easy. I mean, if you don't know the span function,
Yeah.
how does the worksheet help you find the right function?
That's a good point. I guess it would help you in the sense that if you look at the documentation and you see, well, that might be the function, you can try it out immediately and see whether it actually does what you think it does after the documentation. But for actually first getting it, you have to look at the documentation. I agree. Yeah. So it doesn't solve all problems. Yeah.
In case of integrating with some other parts in the application, how far was this worksheet testing? Say you want to fetch data from a database.
Yeah, that's a good point. So right now, the worksheet is stateless. That means every time I press save, it gets recomputed from the beginning. Not good if I want to sort of set up my database and keep the connection open, because it would, but it's the beginning. This is sort of really beta, and it's the first version that's coming out. We have ideas how to make it stateful. So the idea roughly would be to say we have this worksheet object, and what you can do then is you can follow it with other objects, object my state or something like that. And those objects would not be re-executed every time you save the worksheet. So that means you could use that object down here to essentially set up your state and refer to it from your worksheet. But these are sort of refinements. We're getting there. I think here the importance was really the immediacy of the user interface, and what I believe that to make it work, you really need code that is essentially no boilerplate, very concise, direct to the point. If your simple method would take already 10 lines or something like that each time, then it wouldn't be a good usage of screen estate. So it really works only with essentially the functional mode of writing code that says, well, just function equals expression. Here's the result. No complicated flow, no returns, no semicolons, no nothing. So I think that's actually very important for the user experience here. Okay, good. So after this big little parenthesis, let's go and look at Scala 2.10. So we're very close to RC1. As of latest count, I think we have 7 remaining blockers to not exactly sure. Three blockers that involve touching the code base. The rest is documentation, and hopefully we will be able to stage that for a first preview with essentially the core, the Scala core packages in a week or so, and maybe have it for public release in 2 weeks. We're currently under code freeze. Work on the remaining blockers. Most of them are docs. The new features in Scala 2.10 are for the first time all discussed and vetted in the so-called SIP process. So SIP stands for Scala Improvement Process. So I can show you an overview of what that is. So essentially these were all the proposals. And I'm going to talk about quite a few of them. The ones I'm not going to talk about is the futures and promises, even though that's huge. So futures and promises is essentially the new foundation of concurrency that is used in akka, is used in Twitter's libraries, is used in the Play framework, and is essentially the fabric that makes all sorts of concurrency work. It's not tied to actors. It's more general than what actors are. Akka, of course, then builds its actors on top of that. There's another talk by Victor Klang on that, on akka, and he will also talk about futures. Okay, I'm going to talk about some of the others. So let's start with something very simple, string interpolation. So we all know that assembling strings with plus is not super convenient. So we have to write things like books written by, and then we have the author in, year in, and at least I always get the spaces wrong. I always have to go through several cycles to debug that, because I always forget to put, let's say, the space in here, or just write in, and then I don't have a space between the author and the in, and so on. So it would be much nicer if you had string interpolation. So if we could write books written by $author in $year, (books), it's immediately obvious how this thing is going to be formatted, and it's shorter, it's safer. So that would be nice. There's only a problem with that, and that's that $ is already a legal character in strings, of course. We can't just reinterpret that, because that means if somebody meant the dollars to appear in strings, then that wouldn't work anymore. We would break existing code, so we can't do that. So the proposal was, well, let's make a special prefix S in front of the string, where we write S books written by, and then the interpolated one. So essentially, if the opening quote of a string has an S in front of it, then we interpolate, otherwise not. Okay, so that was like reasonable, but this is Scala, and you know Scala doesn't really work that way. So what Scala doesn't really want to do is introduce special tricks for one-off convenience things. We always try to generalize, have something that can be used for many things at once, and not just a single convenience thing. So how can that be generalized? So there the idea is to say, well, instead of the S, let's generalize that to an arbitrary identifier that we can put in front of the quotes of a string. And that identifier then would determine how the string is parsed. So let's see how that would work. So if you write an arbitrary identifier here, just for example, I wrote ID, that would be expanded into this thing here. So there's a new class called a string context, and here I create a new one. And that class takes essentially all the string parts of the interpolated strings. So it takes the books written by, and the in, and then the colon, and then the period in here. And then on that string context, I would call a method id. So id would be the method ID that I'm going to call. And that method gets as parameters the interpolated arguments, author, year, and books. Good, so that's the mechanics how it would work. But that means that I can add further for my interpolators to my toolbox. So here's another one. That's the formatted interpolator. It's just written F. And it is different from the S interpolator in that it doesn't just interpret dollars, but also percentage. So if I follow an interpolated constant with a percentage, then that's a format string. So that thing here would print margin with 2 digits in front of the decimal point and 1 digit up after. Or here's another one that might be useful occasionally, the raw interpolator. That's essentially just like S and F, but it doesn't do any escape sequence processing. So in particular, the backslash here is a legal character, whereas in Java we have to duplicate them every time, which is quite a pain for, let's say, regular expressions. If we want to write a regex, because we have to duplicate every backslash there. Good. So these two are actually given in the standard library, but it doesn't end there. Actually, you could add your own processors, and they could do amazing things. So here's one we already thought about, the XML processor that says, well, let's just put XML inside an XML string. And what that thing would do is it would parse the string and would return an XML tree in our XML library or another one. We could either then use the Scala standard XML or anti-XML or another XML library that builds a tree from that. You could say, well, why do that? Scala has XML literals, so why should we do that? Well, maybe at some point we're actually going to suggest you do that instead of the XML literals that Scala has, just because it would make the language smaller and it would no longer tie the compiler to a particular XML library. That remains to be seen, but I think in retrospect, adding XML was probably a thing in Scala that didn't pan out so well. At the time, it was something very important because when we came out with Scala, there was no parallelism. So we had to find a good reason why people should program functionally. And because, I mean, early 2000s, 2000, 2001, that was a preposterous proposition to program functionally. That was flew completely in the face of everyone that programmed. So the observation was that XML trees are actually a very good example of data that cannot come with methods. You can't put methods into an XML node, not specific ones for the nodes, because the data format is standardized and given. So to process it, you have to come from outside. And that's something that functional languages do well. So that's why Scala has XML in there, because XML was also, of course, very hot and very important then. And we felt that functional processing does a good job with XML, which it does. But of course, nowadays, XML is just one among a set of interchange notations. Another one would be JSON. And it's fair to ask, well, why has Scala XML literals and not JSON literals and not the next interchange format, which no doubt will also appear. So with string interpolation, you can do it all in a user-definable way, which is really cool. But that brings us to one problem and saying, well, I've shown you the S, F, and raw interpolators, and they were all methods in string context. So now I have this idea to write my XML or JSON interpolator. How does the method get into string context? Because string context is a library class. You're not supposed to change that. So in Scala, we had, of course, ways to do that. We would say, well, use an implicit conversion. So the way that would work is to say we would have this class add JSON, and it would take a string context, and it would it would take a string context as parameter, and it would have a method named JSON that takes the arguments and builds a JSON tree. And then all we need is an implicit conversion, which says, well, if we have a string context and we really want to call this method on it, which of course a string context doesn't have, there's an implicit conversion that would map a string context to one of these add JSON instances, and that has the method, and then you're good. So the implicit conversion gets inserted automatically by the compiler. If you've been in Venkat Subramanian's talk yesterday, then he showed you that as one of the tricks that you can do with Scala. Okay, but there's a problem with that. All that is a bit boilerplatey. To do something as straightforward as, say, add a new method to this class, having to go through all these steps, feels a bit heavyweight. So repeatedly, people have said, well, why doesn't Scala have extension methods? Other cool languages have extension methods. Why not Scala? Well, the problem with extension methods is that you can't abstract over them. So you could argue that one of the main purposes of a method is to implement some part of an interface. Methods don't exist alone. Methods are essentially the implementation bits that implement contracts, and contracts are interfaces or traits in Scala. And that you can't do with an extension method. An extension method never can implement an interface. Also, you might have essentially more complicated patterns where you define add an extension method for all types that already have another one. Again, you can't do that with extension methods because it's always one or one or nothing. Whereas with implicit conversions, what we could do here is we could have a trait JSON provider which says, well, that's everything that has a JSON method. So that's my contract. In Java, that would be an interface. And then I could have a class the class add JSON as before, but now it extends JSON provider. And there you go. So that's my implementation. Now my extension method can actually implement a new interface, the JSON provider interface. So I can come from outside string context and in effect make it implement something that is in an interface that it didn't know about beforehand. So that's cool and that's very general, but it's still boilerplatey, right? So all that is that's definitely an objection. So what we did in Scala 2.10 is to say, well, let's make it less boilerplatey. And the way to make it less boilerplatey is actually pretty straightforward. We just say, okay, let me just go back. Of these two things, one of them is superfluous. That conversion here essentially just says, well, it's a thing that takes the class parameter and gives you back a class object. You can generate that. So that thing here you shouldn't need to write explicitly. So the way we do that is simply that we allow you to write implicit in front of a class. And what that means is that the class is a class like you define normally, but you also get an implicit conversion method from the class parameter into the class. That's all that it says. And that then starts to be rather nice. So that now you're actually syntactically in a space where you say, well, now there's nothing to complain anymore. But there's another problem with it, and that's the runtime overhead. That you say, okay, what you do here, unlike an extension method, I create a new object of this class 8JSON every time I want to call JSON. And once I call JSON, the object goes away. Well, it's true that on modern JVMs, often this object actually will be optimized away. So if the hotspot is warm and can inline that, then there's a thing called escape analysis which will get rid of that. But there are strings attached. If the JIT compiler has done it and if the thing managed to be inlined. So if not, then you will still get the object here. Okay, so there's another zip, and that's value classes that comes into play here. So previously, all classes extended object. So that was here. So that's the Scala class hierarchy. We have a class any, and we have two subclasses, anyval and anyref, and anyref is an alias of object. And anyval was the parent of only 9 types, and there were all the Java primitive types plus void. So that's the subtypes of anyval, and every other class that you define extends from anyref, directly or indirectly. So the question is, what would happen if classes could extend anyval? So what we did is we let you do that now. So you can write here a class that extends anyval, and those classes are called value classes, and the elements of value classes are always unboxed. So when I write here like a class meter, So that would be a class that expresses a physical dimension of meter, a unit of measure of meter. And we would have then operations that are checked in the unit of measure. So to add 2 meters to each other, you get a meter. To multiply a meter with a factor, which is a double, you get a meter. But if you would multiply 2 meters with each other, then you would get not a meter, something else, maybe a surface if you have that. And if you add a meter and a foot, then that shouldn't be allowed, right? So that those things are quite useful. And again, just like with the implicit conversion here, is the reason people are hesitant to write that is the runtime overhead. Every time I create a meter object, I have to create an object here, which is annoying. So what value classes do, so essentially by the simple fact that this class extends anyval, what that does is it gives you a expansion that is essentially the same as extension methods. So here's my class after the compiler is done with it, or in the first phases is done with it and has manualed it. So all the methods that you find here would no longer have their own implementation bodies, but would simply forward to 3 methods in the companion object of meters. So these are essentially static methods. And the methods here would take not meters, and they wouldn't return meters, but they would take always the underlying type of meter. So all these methods are simple methods on doubles. And then if you have a usage example, so here's a user code where we say, let's take a meter and multiply it by 2. What that would be translated to is the meters would go away at runtime, and I would just return use double as the underlying types. So if here I have the multiplication operation on the meter class, what that would expand to is this extension method, star extension, and I pass it a double and another double, the 2, and then that extension method would just do double multiplication as what you've seen. The only time that is not the case is if I take a meter and I map it into an any or a generic parameter, because at that time, if we just passed a double, the knowledge that this would be a meter would be lost. So we have to give you a meter. We have to, at that point, so at the latest possible instance, we say, well, before I forget, I'm a meter, and here you go. So I quickly box myself before I go into something that is generic. And it actually turns out that if we use primitive types in Scala, they are also automatically boxed when we need to. It's exactly the same scheme. So when we take a primitive type and we pass it to something that is an any or generic parameter, boxing happens and value classes are the same. Okay, so that was lots of use cases, and one of them is implicit conversions, because if you have this implicit class 8JSON, and now we write extends anyval, then what we get in the end is we don't only get the conciseness, which is close to extension methods, but we also get the speed. No more objects, and the objects are all static. So we have exactly the same thing. Okay, you say, but hasn't Venkat told you that implicit conversions are complicated and you should be careful? And he has, and he was right. So shouldn't we be hesitant to essentially make this into a general usage pattern? Well, in fact, it turns out that the implicit class ones, they are actually fairly uncontroversial. It's the other ones that sort of map from 2 existing types. Those conversions are more difficult. So, but we did something about that as well, and that is essentially to counter. So the Scala way really is to have few constructs of maximal generality. So to talk about implicit conversions are more general than implicit classes, and those are more general than extension methods. Scala always tries to get the most general and orthogonal mechanism, so it got implicit conversions, and they're very powerful. But they can be misused, we know that, in particular when there are too many of them. So they're sort of like chocolate. One piece is very tempting. If you have too much of them, you get a stomach ache. So what we did about that is invent a mechanism that demands that some problematic features are explicitly imported. And the motivation behind that is to say, well, if you have a very powerful and orthogonal language, then that's in a sense also complicated because you have so many features that you can combine in so many different ways, and some of them are maybe not for everyone, maybe only for very few people, maybe. To give you a better guidance there for software engineering purposes, we don't want to get rid of the orthogonality. I think in the end that would be a losing proposition. We always want to be essentially have something that's very general and orthogonal. But what we can do is we can identify certain problematic areas and make you declare that you want those areas explicitly. So here's a thing we did there, that's language imports. So say you have a simple object. Let's simulate JavaScript, and you say, well, isn't JavaScript cool? It can convert a string into an integer automatically. So I have a string, I need an int, well, just pass the string, there you go. And we can do that in Scala, write an implicit conversion that converts strings to int. Good idea? Well, you might think so, but others might disagree, right? So what you do now with that is you get a compiler. If you compile that now, you get a message that says there were 1 feature warnings, rerun with feature minus feature for details. And if you do, then you get a long error message that tells you that implicit conversion method should be enabled by making the implicit value language implicit conversion visible. And it shows you a pointer where you can look up that value, and the Scala doc will tell you more about the discussion, what's good about implicit, what's bad about implicit. And you can shut the compiler up that it won't give you the warning anymore by having an import like that one, which says I want to import language.implicit conversions, and that means I know what I'm doing. But if you're working in a group, then the other people would also know what you're doing because they could look at the import statements and say, yeah, this guy used implicit conversions, and maybe that's not a good idea. And we applied that, eating our own dog food, to the Scala compiler itself. And indeed, I found quite a lot of usages of very dubious usages of implicit conversions that way. Just with that feature, I followed everything. And yes, there was, for instance, one implicit conversion that we decided was a bad idea. So initially, it was a global implicit conversion. We removed it. And then we found, I think, 10 copies of the same conversion in different pieces of the code because locally people thought it was a good idea. So let's just reintroduce this conversion in my piece of code. And that's sort of the things for a general cleanup. It would be really good if you have the import warnings. Okay, so I'm almost done with time. The other big thing I believe that is at least as important as the language features are better tools. So here the highlights are a new incremental builder with plugins for Maven, Pans, and soon also Gradle. IDE improvements, Scala Worksheet you have seen, so I don't need to go into many words to explain it to you. So the future, what I want for Scala, and Scala is a very wide-tent language, so there are many possible directions that you can take it, but where I want to take it is I want to make Scala the language of choice for smart kids. That's really I think the ideal what the language should be. So bring out the simplicity in Scala, focus on the beautiful side, avoid overcomplications. And one thing that hopefully will help here is we are actually running a developer contest which starts Monday this week and runs until end of November. And what we are looking at is essentially small, self-contained, beautiful applications that we can show to other people that bring out the beauty in Scala. So if you know of something, then we would love to hear from you. And there are prizes to be won for the winning entries. Thank you. Well, it wouldn't be my definition of simplicity. There are different ways to define simple, but that's not the one I would be after. My notion of simplicity is not simplicity. I do not want a language in which you can only do simple things. I want to have a language that has simple means to do interesting things.
Can you talk about macros?
Macros.
And the notion of,
So macros are in 2.10 an experimental feature. That means we have them. We are putting them out for evaluation. We want to see what's the best version of macros. We also want to see what are people doing with it. Is it worthwhile what they're doing with it, or is it rather not worth the effort of doing that? I believe the upside of macros, if they work out like we hope for, would be, again, that they would give you the power in the sense that they could keep the core language simpler. There would be stuff that we wouldn't have to do in the core language anymore that we could just as well do with a macro. One example was the things we do, let's say, with manifests and implicit type preification. That's something we could very well do with macros, if macros were standard in the language. Yeah?
I'm very new to Scala, but I'm wondering from Java world, you have annotation and AOP to act on the annotation, something similar.
Exactly the same annotations as in Java. So you can use you can define Java annotations. We have you can define Scala annotations, and the compiler can act on them with a compiler plugin, or the runtime can act on them.
Yeah, you mentioned that functional and imperative are really, really different, and I'm wondering, how do you think the debugging paradigm that we use for imperative languages meshes with functional programming style, and are you planning to change something on it or explore something?
No, the debuggers work actually very well. It becomes simpler. In the end, it becomes simpler. When I say functional, what I've shown you here is purely functional. So there was not a single variable. Of course, Scala has them also, but I didn't show you that. But in an actual application, in a large application, there will probably also always be some imperative computation at the outside. But probably there would be more functional pieces to do sub-computations purely functional than in a classical imperative program. And that's good for the debugger, because when you do that, then you can just essentially skip all that, because you know it won't have a side effect, it won't affect anything, it will just give you the result, and there you go. So I think it's actually the load on the debugger will be much lighter. It will be much easier to deal with things.
Because right now I can see for each type statement, the debugger just kind of sits on the same line.
That will also change in the, that was the thing that that's a good point. Here, where do we have it? Scala debugger. So that's one of the things that will come in the next version, which will ship with 2.10, the next version of Eclipse. So what we had to do there, so that's why the debugger didn't work very well, is that the translation from Scala to Java has to insert quite a lot of forwarding methods and things like that. For performance, it's usually not a problem because these are the first to be inlined. But for the debugger, it was weird because essentially the different forwarding methods, they had the same code points. So you clicked on the thing next, and you essentially what happened is the compiler, you went through one forwarding methods after the other. But for your user perspective, you were at the same piece of code. And that's gone. So the compiler now knows about what's a forwarding method and won't show it to you anymore. The debugger will know that. Yeah.
And that's a compiler feature, not an IDE feature?
That's an IDE feature. Yeah. Yes?
You showed the new Spring version, and that you have to put a vector before.
Yeah.
Break the vector.
Yeah, string interpolation, yes.
Are you going to do a new version without vector compatibility?
No, we won't do that. No, with interpolation, you need to write in front of the screen what you want, what interpolator you want. Yeah. Yes?
I started programming Scala at 1.8, and obviously between 1.8 and 2.10, there's been a lot of changes with the language. Do you see Scala move more towards kind of stability in terms of feature changes and what goes into the language?
When was 1.8?
Back in 2007, 2008.
Okay, 2.8, I think. 2.8, yeah, 2.8, 2.10. Yeah, so I think it's already stabilized quite a bit. So what you've seen here is sort of, in the end, there are minor variations, minor refinements on something, but nothing too drastic, I think. Well, string interpolation, value classes, but syntactically it's not huge. so definitely, as the code base increases, your ability to do large jumps is largely diminished, and that's forced on everyone, including us. So yeah.
What is the message you have for the smart kids that you are targeting Apple for the language work that work in development teams where they're splitting 10% smart kids, 80%,
Yeah.
and 10% people that found yesterday about object-oriented.
Right. We are actually seen quite a lot of teams like that, and I believe it's actually so what you need is a clear understanding what kind of code you will write as a group. So you shouldn't go out in all directions, and once you have that, what I heard is that actually the effort to learn Scala is actually, what I heard time and time again, it's actually much less than I anticipated. So that's what almost everybody I talk to has been saying. Look, we get people and we get people on the job, and after a couple of weeks they're productive, and it doesn't really matter who that is. Because if you stay with the simple and beautiful subset, then it's really not very dangerous. It's really not very difficult. And one thing you could do is follow the Coursera course. That's sort of an introduction to functional programming, and it goes slow enough, I hope. So we'll see how that goes. Yep.
Are you doing much work to help the programmer with, for example, documentation in the fields? For example, if you reduce method that it will pop up, you can use underscore and underscore, and it will combine. That's what I mean with sort of help for new developers.
Yeah. You mean helping with completion and things like that?
More like documentation.
Oh, documentation, yeah.
If you type reduce, it gives maybe an example how to use it.
Yes, absolutely. Yeah, and we are relying a little bit here on the community also to help us with documentation and with tips what to do, with suggestions what to do, with concrete things what to do. I agree that there's definitely things we can do to help new people with better documentation. The other thing we can do and we will do is do some more with the Scala doc, because so one thing I say, a lot of the people who say we come into Scala and now we've found problems and it's not for me, it's too hard. They're typically people who use Scala doc as their primary means of information. So they know nothing, they go into the Scala doc, they try to write it. And for Scala, that's actually not the right way. So there are some concepts that you really should go get beforehand, like read a book, do an online course, these sort of things. If you just want to say hack blindly away and look at the Scala doc, then often you're confused. And part of that is the fault of the Scala doc pages, which have been atrocious, to say the truth. I have improved a lot for 2.10, but I think there's still work to do. Yes?
There are a lot of really feature-rich languages available, such as Ruby and Scala. What do you think are the strongest reasons to use Scala over one of the other options?
Well, they're all fine languages. Scala is statically typed, which the Groovy so far wasn't, and Ruby isn't. I heard there's a static type version of Groovy. I haven't seen it yet, so I don't really know whether that would change anything. In terms of feature comparison, I would say Scala is a far simpler language than Groovy, in the sense that that its feature count is far lower than Groovy, because Groovy has all of... So roughly speaking, I would say currently Scala is about as complicated as Java 7 and will be less complicated by the time Java 8 comes out, whereas Groovy is all of Java plus quite a lot of extra features. So it's by necessity a bigger language.
Is simple build good integrated in Scala IDE?
The builder in the Scala IDE is uses essentially a part of SBT. Yeah, not the.
I cannot run my SBT separately.
You can. There's a plugin called SBT Eclipse that lets you do that. You can use a separate SBT process. Yeah.
Are there any plans to, or is there any expressed interest in improving the NetBeans
we won't do it. We don't really have the capacity to do it. All we can do, and that's already quite a lot of drain of resources, is to say, show the world the one existence proof that you can build a great IDE. JetBrains does a fairly credible job with IntelliJ. They have a completely different approach, but a lot of people are preferring IntelliJ over Eclipse. That's sort of very much a matter of taste. You can't convince one to you give the other a try. And then there are also alternatives such as Sublime Text or Emacs even. And they also have fairly rich Scala modes now. There's a plugin called Enzyme for Emacs that essentially gives you sort of Eclipse-like experience for Emacs. Yes?
Your example about non-determinism, you blame the problem on the mutable state.
Shared mutable state, yeah.
Yeah, that's right, shared mutable state. Because if in your example you have two different mutable variables, it would be fine.
Perfectly.
The problem really is the sharing, not the mutability.
Absolutely. Yeah, I fully agree. It's the sharing, not necessarily the mutability. It just turns out that, and in fact, Scala makes it just as easy to write mutable code as immutable code. It's completely not prejudiced. So you want immutable, you write val. You want mutable, you write var. It's a single letter difference. It's just that the point is, I believe the default should be immutable. You make fewer mistakes that way. To say, well, if you want to introduce a mutable variable, it's perfectly fine, but you should reach for it explicitly. Whereas in Java, it's the other way around. To make things immutable, you have to add a final. So by default, you write always mutable, 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 and then you say, well, I add a final here because it should be immutable. It goes the other way around. So Scala sort of is, it's in terms of length of notation, it's exactly the same, but the recommended default is to go immutable unless you have a reason. Yes?
So when I briefly looked at it, Scala seemed to be significantly faster than Ruby and Java and stuff like that.
That's true, yeah. Yeah.
Basically, why is that? Is it just
Well,
aesthetically high for this time?
No, it's a trade-off. I believe I'm not sure what, it depends whether what is in your language, how straightforwardly that maps into standard Java bytecodes, and essentially Scala maps very, very straightforwardly into Java bytecodes. That's why it's very close to Java performance, sometimes better than Java performance, so it's sort of a wash-up. Yes?
Scala be able to use invoke dynamic?
It will be, yes, sooner or later it will be able to use the invoke dynamic. Probably only when Java 8 is out, because my impression is that invoke dynamic is actually not very fast on Java 7. So I think we want to give it one more iteration for being optimized until we use it. So, but I think on the Java 8 platform, what we're going to do is we're going to change the compilation scheme. So if your target is Java 8, then we will use the same thing as what Java will have, namely method handles and invoke dynamic to use this thing. Because they're definite. Once essentially on the JVM they got the problems out of invoke dynamic, and method handles is definitely the best implementation scheme to use for this sort of thing. No, it isn't. So the Scala numbering scheme is essentially if it's a major new version, and that's 2. So 2 is essentially language version. So it's a 2 version of Scala which has been with us since 2005. So it's very stable. And then, so it's sort of like Java 1, instead of Java 7 and Java 8, the other numbering scheme would still be it's 1.7 and 1.8, JDK and things like that. So we use that scheme. So from 9 to 10, it was a major version. And for major versions, there are problems with Scala that prevent us from being fully binary compatible. So we're not. So you have to recompile. We make it much easier because the tools are there now, and we will have community builds where essentially all the standard Scala libraries that you would look at, that you would typically use would come out of the box with 2.10. So what we want to avoid is this problem that, well, there's a new Scala version, but that library here hasn't been upgraded yet, so I can't move. So we want to essentially move everything at the same time. But the policy is, if it's a minor version, so from 2.291 to 2.9.2, they are binary compatible now, and we have a tool that verifies that. But a major version, we have to break binary compatibility. It's sort of, I really believe Java is very special here, inviolably special. There's no other language that has a similar binary compatibility record as Java. For instance, C# also breaks binary compatibilities between major versions, and in the Microsoft world, people are just used to that, but in Java, it's this thing, is sterling binary compatibility back to Java 1.0. And the reason why they can do it really is that they have the JVM to play with. So without the JVM, there would have been several instances where they would have to break binary compatibility, but they could make a special trick in the JVM to paper over it. So we can't repeat that, unfortunately. Yes?
With regards to this bank record, why is that so important?
Why is what important?
Why is it important to have binary records?
Well, it's mostly when you have systems with many dependencies that you want to avoid the versioning problems. So you want to say, well, I can always use an old binary library. Sometimes I don't have the source, or I don't want to recompile. It depends on your business. So Google, for instance, has a policy where everything is built from source all the time. So for them, it wouldn't be an issue. But there are many others that are different. And I think the whole Maven culture is very much built around binary compatibility. So that's something we have to recognize. Okay, thanks all for coming and for your questions.